Hello there, ATS EVS 105 students. Dr. Shragi here, and we're going to just take a quick tour through what's Chapter 7 in the first edition of the textbook with the rather unhelpful title of Why is Climate Changing? I mean, in many ways, that's what the whole course is about. Here we're going to be going through a number of the different ways in which climate has changed in the past, and we're going to go through and see, are these possible answers as to what's going on now? The kind of questions we could be asking and kind of will be addressing through the rest of the semester are things like, is the planet warming? Why is the planet warming? Should we be concerned about whether the planet is warming? And what can we do about the fact that the planet is warming? Well, let's see that first question. Is the planet warming? I mean, in your day-to-day life, you're going to encounter people who are still of the opinion that the planet is not warming. These might be people in your day, that you actually encounter. They might be people you see online. They might even be people you hear on the radio or see on TV or read their blog. But the truth of the matter is, it is getting harder and harder to find people in public life who actually hold that opinion. For example, this headline here made the news a couple of years ago, where a particular magazine came out and had a headline about, "Don't worry, global warming is all not going to happen," or something like that. But the headline is actually pretty misleading. The article doesn't actually say that the planet isn't warming. The article actually has a lot of contrarian opinions about whether or not it's being caused by people, but the article is not actually saying that the planet isn't warming. In the same way, this is actually a book that is out that is very much of this opinion that humans are not causing climate change. It's a famous book. It's a terrible book. Just to read you the little blurb here, it says, climate, sea level, and ice sheets have always changed. True. And the changes observed today are less than those of the past. There are past changes that are as big or bigger. Climate changes are cyclical and driven by the Earth's position in the galaxy. I don't know about that. The sun, yes. Wobbles in the Earth's orbit, true. Ocean currents, true. And plate tectonics, true. In previous times, atmospheric carbon dioxide was far higher than that of the present, true, but did not drive climate change. False! That's obviously not right. No runaway greenhouse effect or acid oceans occurred at times of excessively high carbon dioxide. Well, I don't know about runaway greenhouse effect, but clearly acid oceans did. During past glaciations, carbon dioxide was higher than it is today. There may be past glaciation events where carbon dioxide was higher than it is today, although you'd be going way far back in geologic time when the solar output was very different and so on. The non-scientific popular political opinion is that humans cause climate change. Do we have reasons for concern? Yes, very much we do, but the author of this textbook makes his money by denying that, and we have to understand that. But in fairness, this is a terrible book. This is a known entity, and this book is mostly advancing opinions that are contrarian and so on, and that's how they make their money. Another group that you might suspect to hold some pretty anti-scientific opinions on the subject of climate change are politicians that are appealing to certain demographics and certain political groups and so on. And honestly, you can pick any group of politicians and find awful things they say, but because of where we are in history, let's talk about the folks who were campaigning for the Republican nomination in the 2016 primary season, because they were a group that was largely courting people who are opposed to climate change, opposed to making changes in order to address climate change and so on. So what I did is I found this page on the Hill that has actual positions of each of the candidates from their websites and so on. And just to highlight, again, we could be snarky about any group of politicians' opinions, but just to be clear, like for example, Donald Trump. Quote, unless somebody can prove something to me, I believe there's weather, I believe there's change. Trump told radio host Hugh Hewitt in September, and I think it's very low on the list of problems. So I'm not a believer, and I will, unless anybody can prove something to me. I believe there's weather, I believe there's change, I believe it goes up and it goes down and it goes up again, and it changes depending on years and centuries, but I'm not a believer, and we have much bigger problems. Whether that isn't a very Donald Trump thing to say, sort that out and decide. I guess he says unless somebody could prove it to me. Well, that's good. He's open to someone proving, but most of that's pretty contrarian. On the other hand, he's not saying climate change isn't happening. He says it's natural, it goes up and it goes down. Okay, this is not the most unsophisticated opinion. Ted Cruz. The radical left loves attacking people as anti-science when anyone dares to question their computer models on global warming. Well, kind of, yes. I mean, I don't know about questioning them. If you have informed questions about, things that are happening in the model, that's different. But just to say, I don't believe in models, that doesn't work. Models are a tool of science. You wouldn't have your cell phone. You wouldn't have chemotherapy. You wouldn't have any of the technologies and techniques in our life if it weren't for these kinds of models, of numerical models and conceptual models and so on. They scream, you're anti-science, when someone points out, for example, that in the last 17 years, satellite data shows that there have been no warming whatsoever. That's a complicated issue. This is the so-called global warming pause. Certain satellite archives do show that global warming slowed down in the last 10 or so years, but it's a statistical anomaly associated with the very large El Nino at the beginning of that period in 1997-98. But we'll be talking more about El Nino later in this lecture. Just to drag through a few more of these, how about Marco Rubio? Marco Rubio said he believes in the science behind climate change. Hooray! He opposes U.S. efforts to address it in the U.S. if other countries aren't willing to do the same thing. Oh, well, that might be awkward, although usually it's the other countries who are willing to do it, not the United States. He's vowed to undo President Obama's clean power plan. He urged the United States, he said the United States cannot limit its economy to tackle climate change. Well, kind of by definition, you're going to have to. Oh, good old Ben Carson, how about him? Ben Carson told the San Francisco Chronicle back in September that there is no overwhelming science, that the things are going to be man-caused and not naturally caused. Give me a break. That sounds like a very informed opinion on the subject. Although, interestingly, later on the article it says there, a Carson spokesman told CNN later that the candidate is not a climate denier, but rather a questioner, and that he could be persuaded. Again, it's easy to be snarky about such things, but actually I'm always open to the fact that there's people who are willing to have their opinion changed on the basis of evidence. That's not a wrong thing. I can accept that. How about Jeb Bush? Bush's opinion is very similar to Rubio's. Bush says that he believes in the science behind climate change and mankind's role in causing it. Well, that's good. But he's wary of federal intervention to solve the problem. Oh, okay, well, I'm not really sure if you don't think governments can do this. I'm not quite sure who you think can. President Obama's climate role, he told Bloomberg News, is irresponsible and ineffective. He said private sector innovation is a source of a lot more solutions than any government-imposed ideas. Well, perhaps some of these ideas could be coming from the private sector. There's not a lot of history of that in this kind of situation, but that's not an entirely impossible position. How about Rick Santorum? Santorum questioned the scientific consensus on climate change, including the much-cited fact that 97% of scientists believe in man-made global warming. Okay, so he denied, that's kind of an interesting position that he's denying something that's clearly a fact. Beyond that, he said he opposes the work Obama has done on climate issues, including a limit on surface-level ozone that he said could destroy manufacturing jobs. Not entirely sure how he thinks manufacturing jobs are causing ozone. Let's talk about facts. A lot of things cause climate change, he said. Well, that's true. There are a lot of things that produce climate forcings, although anthropogenic greenhouse gases are certainly at the top of the list. Mike Huckabee. The science is not settled on climate change, Huckabee told NBC in July, though in the past he said that humans need to take care of the Earth. That's an opinion I very much respect. There are a lot of people who are not so much worried about climate change so much as they are interested in issues of stewardship of the resources and so on. I can respect that. Furthermore, he said, I think one of the ways which would really help a lot of people is to use the energy that we have until we develop an energy that is not economically viable. Oh, so he says burn it and then hope that in the future somebody finds something else. That's a bad plan. Climate change is maybe the wrong question. Good stable energy prices and making America an exporter of energy, not just for economic reasons, but quite frankly to disrupt the balance of power with Russia, Iran, and the Saudis. This is a game changer and America needs to be using the resources it has. Wow, that's a terrible answer. But, that's the nature of politicians and so on, is that they are trying to change the questions and so on. And finally, I wanted to bring up Rand Paul, who's often the light in the room. Rand Paul, the Kentucky senator, said humans do play a role in climate change, but not as much as nature itself. Okay, well, in the sense that, if we lived on a very different planet, twice as far from the sun or something like that, yes, we'd have a bigger difference than what humans could cause. While I do think that man may play a role in our climate, I think nature also has a role, he said in a November issue. Oh my. But did you notice that none of these people actually expressly said climate change is not happening? I mean, realistically, you may have a crazy uncle who forwards you articles like that on Facebook or something like that, but by and large, that is no longer in the public sphere. The idea that the planet is warming is pretty accepted, more so than you might even think. A broader question that we need to tackle is, why is the planet warming? Later in the next module of the course, we'll tackle those last two questions about should we be concerned and what should we do about it. But let's focus on why the planet is warming. Now, we have kind of been tackling certain aspects of this problem all semester as we have been talking about like what greenhouse gases do and changes in albedo and aerosols and all of these kinds of factors. We've been talking about how we could use models to test these ideas and so on. What I want to do here is, though, I want to actually take apart 5 things that we know in the past have resulted in climate change and figure out, can we blame the current climate change on these things? This is an important scientific question. We know climate is changing. We know it's changed in the past, that we had nothing to do with it. We better be able to make some decisions about these things on this list as to whether they are part of the story. So let's focus first on continental drift, also known as plate tectonics. As you probably know, the surface of the Earth is made up of these crusts made of rock, these plates, to use the right word, that are sort of floating on a big blob of magma, and they move on very, very slow timescales. They move about as fast as your fingernails grow, but over the course of millions of years, that can result in a very large displacement. The continental plates shift, and they grind past each other, and they crunch into each other, and they build mountains, and so on. And such changes can certainly produce climate change through a variety of mechanisms. One of the most important ones from a climate change perspective is the arrangement of continents, and whether or not there is a continent at the poles. The arrangements of continents determine whether or not these big ice sheets form. Remember, ice sheets are the ones that are on land, like on Antarctica or on Greenland. They can be miles thick. They have enormous amounts of fresh water trapped in them. Ice sheets only form in places where the summer temperatures are low enough that the snow that fell during the winter doesn't melt in the summer. And that happens mainly on land at high latitudes. Well, as the continents drift around, sometimes, like right now in Antarctica, there is a big continent at the South Pole, and for that matter, in the Northern Hemisphere, Greenland is a very large landmass that's at quite high latitudes. We have these big, thick ice sheets on big landmasses near the poles. This has an interesting climate feedback because when you make these big ice sheets, they change the overall albedo of the planet. And as a consequence, if we have a big chunk of the planet covered with a big white sheet of ice that's miles thick and isn't going to melt easily and so on, you have overall changed the energy balance of the planet. Overall, the planet's going to be colder if there are land masses at the poles where these ice sheets can form. Another way in which plate tectonics and continental drift can result in climate change is by the way that the arrangement of the continents affects ocean currents. Ocean currents redistribute heat around the planet in ways that can result in ice sheets forming or not forming, or sea ice forming or not forming, all of which has big consequences for things like the albedo of the planet and the energy balance of the planet and so on. This is actually a rather complicated oceanographic issue, but I can illustrate for you one place where the difference is not so hard to see. Let's take a look here at a map of the Arctic Ocean. There's really only one place at the current time in human history where water can get from the relatively warm Pacific into the Arctic Ocean, and that's through that little strait, the Bering Strait, between Alaska and eastern Russia, and it's pretty narrow. At present, a small amount of warm water from the North Pacific can get up through the Bering Strait and up into the Arctic, keeping the Arctic warmer. Also, some cold water from the Arctic gets away from the Arctic and down into the Pacific this way. Both are ways of warming the Arctic, right? Bringing cold water out and pushing warm water in are both ways of warming the Arctic. And at the present time, there is a small but real way for warm water to get through. If the continents were to move farther apart and widen the Bering Strait, there would be a greater flow of water, and overall the Arctic Ocean would be warmer. Or if the Bering Strait were to close, then there's no flow of water between the North Pacific and the Arctic Ocean. And then that will obviously have consequences for like whether or not sea ice forms and so on. There's other ways in which continental drift and plate tectonics matter for climate. The arrangement of the continents is what controls things like where monsoons happen and that produce enormous amounts of precipitation and chemical weathering of land masses. For that matter, the uplift of mountains exposes rock for erosion and chemical weathering and so on, all of which transfers, has the potential to transfer carbon to different parts of the carbon cycle and so on, all of which has consequences for climate. All of which is, by the way, fairly complicated as to figuring out whether that will make the climate warmer or climate colder, but there's no doubt about it. Plate tectonics and continental drifts certainly can change the climate. However, these processes take literally millions of years. We can't modify, we can't say that the amount of climate change we've had since the Industrial Revolution is because during that period of time California has drifted a few feet farther to the west, or Antarctica has drifted a few feet farther away from South America, or the Himalayas have pushed up a few more inches or something like that. On the course of millions of years, it's going to be hugely important, but on the course of like a few decades or even a few centuries, absolutely not. Alright, before we move on to part 2 of the lecture, I thought we'd just do 2 quick questions. Question 1. Overall, the planet tends to get cooler during geologic periods in which there is blank at the North Pole and the South Pole. Does that happen when there's land at the poles, or does it happen when there's ocean at the poles? Make a choice from those 2 options and get a little feedback before you move on to question 2.